All right. How are you there? M3 students. Welcome to our class, science class for Meta M3. Now it's about light, chapter 7. The topic is 7.2 here in refraction of light. Okay? I want you to go over this and even turn on your translation here or caption so you can repeat it several times. All right? Okay, now light can pass through transparent media such as water, air, glass, and certain types of plastics. Okay? And so light travels at different speeds in different media. Therefore, when light passes from one transparent medium into another, it may slow down or speed up. The changes in the speed of light and causes the light to bend or change direction. Now, let's learn some amazing facts. So light travels at different speeds in different media. Speed of light in air is 300,000 kilometers per second. Wow, that's very fast. Speed of light in water, 225,000 kilometers per second. And speed of light in glass is 197,000 kilometers per second. Now, you can do this activity. We don't need to do it. Studying the refraction of light, like you need materials or apparatuses like glass block and ray box with a single slit. Now, here's the procedure. A ray of light is directed at an angle to a glass block as shown in the figure below. Okay? What happens to the ray of light is observed. Okay? Look at this. There's a direction of ray of light to a glass block. Now, step two, repeated. Step one, I should say, is repeated, but this time the ray of light is directed vertically to the glass block so that it travels at the right angle with the glass block. What happens if the ray of light is observed? Okay? Now the figure shows what happens to the ray of light when it is directed at an angle to the glass block. Here's the normal. And then you see, it's refracted. The light bends towards the normal when it travels from air to glass. Now here, the light bends away from the normal when it travels from glass to air. Number two, when the ray of light is directed vertically to the glass block, the light ray travels in a straight line. Now, here's the discussion. Number one, when light is directed at an angle to the glass block, it is refracted. When light is directed vertically to the glass block, it is not refracted. Conclusion. Light is refracted when it travels at an angle from one transparent medium to another of different density. Now let's watch this video, okay?
In progress. Hello friends, welcome to our channel Learn and Have Fun. In this video, we will learn about refraction of light through a glass slab. For this activity, we will take a black paper as a background for laser beam. We have placed 4 tablets on the black paper which serve as a platform for the glass slab. Friends, these are simple paracetamol tablets used to raise the glass slab slightly above the surface for better clarity of the laser beam. For the activity, we are taking a powerful green laser torch. Now switch it on. We can observe the laser beam travel in a straight line in air medium, but when it is passing through the glass slab, it bends. This bending of laser beam or visible light when it travels from one transparent medium to the other is known as refraction of light. Let's first discuss refraction with normal incidence of laser beam. Here, the laser beam is falling normally on the glass slab. That means angle of incidence is 0 degree. So here, light travel straight in glass slab without any bending or refraction. Now change the direction of laser beam and increase the angle of incidence. You will observe a slight bending of laser beam towards the normal in the glass slab. Increase the angle of incidence further and you can see the amount of bending of laser beam also increases. Observe the refraction of laser beam through a different angle for better clarity. Here you can see in air medium the laser goes straight, but when it enters the glass medium, bending takes place. Let's now understand the phenomenon of refraction deeply. Here we have two different medium in which light is traveling, air and glass. In air, the speed of light is high, very close to its maximum speed in vacuum, which is 3 into 10 to the power 8 meter per second. And in glass, light travels slower, approximately 2 into 10 to the power 8 meter per second. We call air as rarer medium since light travels faster in it, and glass as denser medium as light travels slower in it. The ray which is falling on the glass slab is known as incident ray. The incident ray on entering the glass slab bends and then it is known as refracted ray. The ray that comes out of the glass slab is known as emergent ray. A line perpendicular to the glass slab at the point of incidence is called the normal. The angle between the incident ray and the normal is known as angle of incidence. Similarly, the angle between refracted ray and normal is known as angle of refraction. And angle between emergent ray and normal is known as angle of emergence. If light is incident normally on the glass slab, then angle of incidence is 0 degree. In such a case, the ray will go straight even though there is a change in speed of light, as it is the shortest path through which light can travel in the glass medium. There is no bending occur in this case. As we increase the angle of incidence of laser beam, that is, any value other than 0, it bends. Here in this case, it bends towards the normal as it travels from a rarer medium air to denser medium glass. When light comes out of the glass slab, opposite happens. Light bends away from the normal. This happens because light is traveling from a denser medium glass to a rarer medium air. Watch once again the laser show as we change the angle of incidence from 0 degree to 90 degree on both sides of the normal. Now we are using two laser torches which are joined using glue. We change the orientation of the laser beam such that both the laser beam appear to coincide when viewed from the top. That means from the camera angle we will see only one laser beam instead of two. We now pass the lower laser beam through the glass slab and the upper laser beam continues to move in the air. You can see the emergent beam which come out of the glass slab is parallel to the incident beam. When observed from a different angle, you can see two laser beams. One is passing through air and the other through glass slab. As the opposite side of the glass slabs are parallel, you can easily prove through your knowledge of geometry that emergent beam should be parallel to the incident beam. Watch it again. Now we will pass both the laser beam through the glass slab. Observe that the same amount of bending is taking place for both the laser beam as the angle of incidence is same for both. Now we will use two glass slabs to show how ray of light goes from air to glass slab 1 and then air and again to glass slab 2. Now let's observe how bending of light takes place if we replace the glass slab with a plastic box containing water. We will observe laser beam is not clearly visible in the water. Now I am going to add few drops of Dettol in water to increase the scattering effect. It will make the laser beam slightly visible in the water. Now pass the laser beam through this water. You will observe bending of light in water is less as compared to bending of light in glass. This shows water is rarer than glass. Repeating the activity again with laser going from glass to water. This is our attempt to explain the phenomenon of refraction using laser beam. Hope you like it. Please like, share, comment and subscribe our channel. Learn and have fun. Thank you.
Right. Okay, right here. Let's learn some hot tips. Now, one, reflection of light is the bouncing of light off the surface on which it falls. And then refraction of light is the bending of light as it changes its speed when passing from one transparent medium into another at an angle. And so the bending of light array when it enters in a medium of different density is known as the refraction of light. When the light travels from a less dense medium to a denser medium, it slows down. The light is refracted towards the normal. When light travels from a denser medium to a less dense medium, it speeds up. The light is refracted away from the normal. Now you see here, we have the air, glass, air. If a light ray hits a transparent medium at a right angle, The light passes through the medium at a straight line. The light is not refracted at all. Refraction of light gives a false impression of depth and position of an object. Now you see here are some examples. Ponds and swimming pools appear shallower than they really are. This is because the light from the bottom of the pond is refracted as it moves out of the water into the air. Okay, so you have the bottom of the pond, the air and water. You see the actual depth, but your eyes, as an observer, will see it that it looks like it's until here. The depth here, apparent depth is here because of the refraction. So the pond appears shallower than it really is due to the refraction of light. When the refracted light enters the eyes of an observer, he sees an image of the bottom of the pond that is shallower than the actual depth of the bottom of the pool. Now, you see this pencil in a glass of water appears bent. This is because the light from the pencil is refracted as it travels from the water into the air. Now, when the refracted light enters the eyes of an observer, he or she sees the image of the pencil somewhere above the bottom of the glass. This causes the pencil to appear bent. Now, a mirage is an optical phenomenon. Look at that. It's an optical phenomenon that creates an image and is caused by the layers of the air of different temperatures and thicknesses. Mirages happen in sunny days. The sun heats up the ground, which in turn heats up the air just above it. When light passes through the layers of air, it refracts, fooling our eyes into seeing something which is not present. The mirage of puddles of water, often seen in deserts or roads, is actually the image of the clouds in the sky. Okay? Now, here is the cloud and the cool air, there's the warm air, the hot air, and the very hot air. Now you are in the vehicle. You see how it is refracted. The light is refracted as you see it. And so what you see here, if this is the pool of water apparent image, this is what you see, but actually it is a formation of a mirage. Now look at here from a prism. The weight, the white light enters into the prism and it is refracted into different colors. So when light passes through a prism, a triangular based transparent block, this one, the light is refracted twice. One, two. And when it enters and leaves the prism, both these surfaces are not parallel. So the light is dispersed into a spectrum which contains red, orange, yellow, blue, violet, indigo, which each color is refracted by a different amount. So rainbows are produced when light is both reflected and refracted by the tiny water droplets in the air. All right. So we can only see a rainbow when it is drizzling and the sun is low and behind us. So the light enters the water droplet and is reflected from the back of the droplet. The light is refracted twice when it enters and leaves the water droplet. This separates the light into its components. The water droplets act like prisms. Okay? I think it's a lot clearer now. Do you understand? All right. Now let's watch this video again.
ช้อปปี้ส่งฟรี0 บาททั่วไทยช้อปปี้ถูกชัวร์การันตี
when it enters from one medium to another in daily life. Refraction of light. Have you observed the path of light when it enters from one medium to another in daily life? Does it move along straight line path or changes its direction? Let us observe some of our day-to-day experiences. For example, when pencil partly immersed in water, it appears to be broken at the interface of air and water. A clear pool of water always appears to be shallower than it actually is. A coin placed at the bottom of beaker containing water seems to be raised. When a thick glass slab is placed over some printed matter, the letters appear raised when viewed through the glass slab. Why does it happen? Let us understand the reason with this illustration. Let us consider a water tumbler and a pencil. When the pencil is partly immersed in water in a glass tumbler, it appears bent or broken to the observer. We know for a fact that the pencil is not bent at all. It just appears to be so. In this case, the light reaching observer from the portion of the pencil inside water seems to come from a different direction compared to the part above water. This makes the pencil appear to be displaced at the interface. Does the pencil appear to be displaced to the same extent if instead of water we use liquids like kerosene or turpentine? Will the letters appear to raise to the same height if we replace a glass slab with a transparent plastic slab? You will find that the extent of effect is different for different pair of media. These observations indicate that light does not travel in the same direction in all media. Definition. When a light ray travels from one optical medium to another, it suffers a change of direction at the surface of separation of the two media. This is known as refraction. Activity. Suppose we were to place a coin in a glass of water. The light bouncing off the coin under water, for instance, would have to first travel through the water and then the air to reach an observer's eye. At the boundary, it gets refracted and reaches the observer's eye, thus appearing to be slightly raised.
All right. Now that you have seen it, okay, that's interesting, right? Okay, let's resume. Now that we have watched it, I want you to work on this. Conclusions. When light travels through different transparent media such as air and water or air and glass, it will refract. The speed of light changes when it travels through them. Reflection of light makes ponds appear shallower and pencils in a glass of water appear bent. Prisms disperse white light into a spectrum of 7 colors due to refraction of light that happens twice. A rainbow occurs due to refraction of light by droplets of water in the air. We can only see a rainbow when it is drizzling and the sun is low and behind us. So check your book here. Check how much you understand this subtopic. Go to test yourself 7.2 on page 136 and come to me for bonus points and then you post it in your line group. All right, that's it for today. See you in the next video.